Welcome. We're going to be exploring a bit in a really interesting data set I found called the San Francisco Bay Area bike share data set. This is a data set of bike trips from August 2013 to August 2015. If you're curious, this data set is available on Kaggle, and it describes a bit about what's available in each of the tables and each of the columns. You can download it as a SQLite database. You can also download this as CSVs and import it into a different platform like Postgres or like a SQL Server. Really, whatever you're comfortable using is fine. Right now, we're going to actually be working in SQLite because in SQLite Studio on a SQLite database, since this is the database type that's being used. And in addition, it's a pretty easy desktop application to set up without having to set up a server. You can actually do a lot of very quick imports from it. Like you can import directly from a CSV and it auto creates a table for you. So let's start taking a look at what's in the actual tables. So I'm actually going to click into this. So this one is the station, which is the names, the locations, and the city, as well as the installation date of. You have all of the different locations here. Let's take a look at it. How many records are in the station table? And there are 70. Let's take a look at how many are in the status brief. I'm showing this to you because this table, the status updates on the bikes, has over 70 million records, and that's actually quite slow to load, so I'm not going to do that here. So let's take a look at the brief status. This is selected every 300th row in the status table and has a truncated version of what's available. So in this, there are 250,000 rows, and this is generally what's available in terms of the data set. So the station ID, how many bikes are available, how many docks are available, and these are directly proportional to each other. So bikes are what's there in terms of bikes, docks are empty docks, and then this is the time in which that was recorded. So trip table is also a bit long, because this is trip data, and this looks something like this. It has a lot of similar information, like the station name, like the starting, the ending, whether or not the person getting the bike subscribes to the service or is a customer. So like, do they have a subscription versus are they just paying for the bike to use it once, and then another table about the weather, which we're not going to look at as much. Let's start by taking a look at the stations. So if you do this, the one interesting thing here is the stations, we have the name. So let's start by selecting the station name. So I'm going to put name, and I'm going to, so here are the results. There are 70 unique names. Let's add in some interesting information from the trip table. So trip, we're interested in maybe how many trips were made starting at each station. So starting station ID, let's do a count of start station ID. And at this point, since we added two tables, we're going to have to add a join. On which columns, let's take a look at what's available in each. So in this case, the ID column this is the station table's ID, which should be identical to the start station's ID. Column available here in the trip table, so let's join these two. And we're going to do an inner join, because if you actually look here, there might be a few blanks. There might be some data that doesn't match up. Okay, this is going to take a while because this is a large table. So start station ID. And give each of these an alias. and then start putting the alias names in here. There you go. We have cities here. We have San Jose, Redwood City, Mountain View, Palo Alto, and San Francisco, and a couple of others. Okay, interesting. See, you know what we actually forgot here, which is one thing that SQLite Studio will allow you to do is to forget your group by clause. So you can actually do group by one, or you can do group by name. One just gives you a position of group by the first column that you selected. We won't use this in most of our DataCamp courses, but this is an approach you will probably see a lot. And see, now it actually properly aggregated this. So we have the name of each station, and then we have the number of starts for each station. So yeah, this query is let's say we wanted to order by 2 descending to see which one's the most popular station. And it seems the San Francisco Caltrain is the most popular by a pretty large margin. And then if you look down here, Redwood City Public Library has very few trips recorded during this time. So let's move on to another question and start actually expanding on this. So let's take this part of the query, copy it over to the next line. And let's say we want, instead of name, we want to expand this out into different columns using a case statement. So what you would actually start with here instead of the name, since you'll notice that the station table, like each name only belongs to one city. So I want to actually take a look at columns with each city. And you could leave this in rows, but then it'll just, you'll have a bunch of zeros because this only belongs to San Jose. And I can actually show you what that looks like. So let's do case when. Let's go with s.city equals then what? Then return the station ID and end, and then surround that with a count. And again, group by. So yeah, you'll see that there are a few stations here that belong to San Jose, and those will return results. Everything else that isn't a part of the city will return a 0. So if we take this out, we're just going to get a count within San Jose. And we can add to this. We can do count, copy the exact same syntax over into the next line, and add the next city that we want to put. So let's do Redwood City. And now we're just going to generate a bunch of columns about each city. And let's add one more, because you can add as many case statements as you want for as many conditions as you want. Let's go with San Francisco, because they probably have a lot more. And you'll notice here I generated an error just above. Usually, like in any, like in Postgres or in SQLite or anything, you'll get error messages that tell you that there's some kind of problem. So here it said near from statement. So somewhere around here, either just before or just after, there was an error. And in this case, there was an extra comma. And you'll notice that these two aliases were accidentally identical. So if you have identical aliases, depending on what like SQL interface you're using, it'll usually give it like a duplicate number, like either 1 in parentheses or underscore or something. That's pretty common. Cool. Let's add one more and then start expanding the actual rows so we can take a look at some more interesting data. One more city here. What do you think? Let's go with... One thing to keep in mind here is make sure that you get your text fields identical, because if this is off by like one character, you're just gonna return a 0. Cool. Okay, so we have a sense as to how to create this kind of crosstab where we have like data that would normally, if you were counting this and grouping this, appear in one separate row. You can turn this into columns. And on its own, this isn't the most meaningful. So let's actually work on expanding this. So this query, I'm going to comment it as count of trips by starting location. And let's move on to the next one. So what we can do is sort of expand on this. Let's take a look at the results of the first query again. So this tells us what some of the most popular stations in which trips were actually started. And let's add s.id here, and I'll show you why in a moment. So we have for each trip in the trip table a starting location and an ending location. So if we go with select trip start station name, we can move on and then also add a case statement the way that we did before, but instead of the city, let's take a look at conditions based on the actual location. So we know that these are the most popular stations, and now we know these are their IDs. So this column is also available in end station ID right here. So let's see how many trips were started and ended in different locations. So case when end station ID equals 70, then what do we want to count? We can count end station ID, we can count end station name. Either one of those will work. And we're giving this an alias of SF Caltrain 4th. And let's add another couple and see where do some of the most popular starting trips also end. So we can go to station ID 69, that's Caltrain 2. Let's add another. When ID equals 50, that's and this is all from the trip table. So you'll notice I didn't add an alias here since we're only selecting from one table. Let's not forget to group by. Let's see what we got. We're going to get a lot of zeros because we didn't put in complete data, but we have a sense as to where some of these trips tend to begin and end. So we knew that San Francisco, Townsend at 4th was the most popular starting point, and it seems like quite a few of the trips actually end here at the Harry Bridges stop. And I don't know very much about San Francisco's geography, so maybe this might be news to some of you, not surprising to some others. Let's add a few more. So basically what we're creating here, we're creating a crosstab. Let's go with the next one on the list. There we go. In a crosstab, it's kind of like a pivot table if you're familiar with spreadsheets. So you have data on your rows, data in your columns that you want to split out and compare. And this gives you a set of numbers by which you can actually compare that data. And case statements are a great way to do that. You know, instead of a count, you can always do, like if you have an actual column that you want to take a value or an average of. In this case, you don't want to take an average of ID because that's not exactly meaningful. You can see how many subscribers there were. So let's actually go with the subscriber column. So subscription type tells us whether or not someone's a consumer or like someone who pays for an actual subscription on this trip. So and let's select distinct to see what's available to us. So either you're a subscriber or a consumer. So let's start again and look at and let's do something a little more layered in terms of calculations. So we can count this pretty easily. So case when subscription type equals then so customer versus subscriber. Okay, so we have a sense as to how many folks tend to, like at each location, you tend to have like a count of subscribers, a count of customers. And if you look across the board, you can see that the majority of people getting a bike at pretty much any location tend to be subscribers. That's definitely more common. But let's say we want to know, so this query looks at count of trips by station by subscriber customer. Let's add to this. Let's say we want to know on average, how many bikes or how many trips are taken by subscribers or customers. And what you can actually do is take this query and turn it into a subquery. And that's, so we're going to start by taking this and put it inside parentheses, because we're going to select information from this query. Let's go with average. Okay, so so just like any other table, this result set, basically we're treating this result set as if it's any other table in the actual query. So you do that as subquery. So let's select the average of sub count. And let's take a look at this for a second. So we basically just copied an entire query, put it in parentheses, and then put it inside the from statement. So this is one of the most basic types of subqueries in from, or subqueries in general is just a subquery in the from statement. So we're giving this the name subquery, and for the purpose of this query, your SQL environment will treat this as if it's any other table in your actual database. So what the order of operations is, when you hit run, like I'm doing here, the first thing that SQL will do is process the information in these parentheses. If you'll remember like PEMDAS or order of operations from mathematics, where you run like parentheses and then exponents and then multiplication, and there's an order in which things are processed, SQL does that too. And things inside parentheses like this, which are subqueries, are run first, and then information is taken out in here. So now we have a sense that on average, across all of the stations in which a trip was started, about 7,000 people, or 7,000 of these trips were made by subscribers, and about 1,400 were made by customers. And subqueries can be in any of these. Let's say instead of just having one row here, we want to actually compare things to the average. What you can do is you can put a subquery in select. So let's go with select count of all of the start. And let's see what happens here. So this basically took the overall average of, or the total of every single trip that was ever taken, and put this in select. And in this case, it might be useful or might not be. Like this could be used to compare, to be like, oh yeah, so we see that this number is pretty large compared to the overall number of trips. And this is a subquery in select, and these are most often used for comparisons. You can also add to them, because what we're doing so far are the types of subqueries that if you actually just copy the entire thing out, you can run it on its own and you get a result, and that's what's called a simple subquery. If you add a where clause where you actually connect information from this to a column outside. So let's give trip an alias t. And let's give trip in here an alias t1. So we're going to match identical columns where the column in here equals the column out here. And that's going to give us a new useful piece of information. So t.start station ID equals t1.start. So basically, this has created a matching value, and this is going to take longer to run. As you remember, the trip table is pretty large, but across the board, when you do this kind of subquery that connects something from an inner query to an outer query, the processing time is always going to be longer. But now we very quickly generated the total trips for each station. So this, for example, we've got this value here equals the sum of these two. And on its own, again, it's only as useful as however much you want to visually compare them to. But yeah, calculations like this are really just a small sense of things that you could learn by working with different types of subqueries. So simple subqueries, correlated subqueries. There are also other different types of subqueries as well. So yeah. That's pretty much it. I hope you find this useful, and please check out our intermediate SQL course available on our platform, as well as any other course that we have in SQL or other topics. We're always expanding our library, and we have a lot of really exciting things in the pipeline. That's it on my end. Thank you.